Let us solve some questions on number systems. I have taken all these questions from Oswaal Books. So the first question is 1 upon root 2 is a oblique and dash number. So here we have got four options. A option is rational, B is irrational, C is fractional and D is none of these. So you have to look out for the correct option here. So you know that the product or the quotient of a non-zero rational number with an irrational number is irrational number. So here we have 1 as a rational number and in the denominator we have root 2 which is an irrational number. So as per the rule you are dividing here a rational by an irrational. So the answer is an irrational number. The correct option is B. Now let us take the second question. So the second question is 5 raised to power 6x is equal to 125 square, then x is equal to dash. You need to find out the value of x here. So we are going to use this to find the value of x. So we have 5 raised to the power 6x is equal to 125 square. So let us make the base same and try to solve it. So 125 we can write it as 5 cube. So let us write it. So this is 5 cube whole raised to the power 2 and on this side we have 5 raised to power 6x. So now we can multiply the exponents. So you will have 5 raised to the power 6 and here you have 5 raised to the power 6x. So you can see that there is an equality sign here. That means this number over here is equal to this number over here. And here the base is 5 and here also the base is 5. So these two numbers will be equal when their exponent is also same. So we can rewrite this as 6x is equal to 6. So x is equal to 1. So the correct option over here is C. Now let us take the third question. So we have value of 7 raised to power 10 into 8 raised to power 10 is dash. So here we are going to use this law. A raised to power p into b raised to power p. So what we will have? ab whole raised to the power p. So using this law we can multiply 7 into 8. So 8 into 7 is 56 whole raised to the power 10. So the correct option is B. Now let us take the next question. State true or false. So every real number is represented by a unique point on the number line. Also, every point on the number line represents a unique real number. That is true. Every real number has got a unique representation on the number line. Or the same thing we can say it in other words that every point on the number line represents a unique real number. So this is true. Let us now take the fifth question. Write the simplest form of a rational number 225 divided by 1250. So there are many ways to solve this. If you divide both numerator and denominator by highest common factor, you can write down the simplest form in one step. Or whatever common factor you can find out in both numerator and denominator, you can cancel them out. Or you can write down the prime factors of 225 and 1250 and then you can cancel the common factors. I am going to divide both numerator and denominator by 25. That is the highest common factor of these two numbers. So 225 divided by 1250. So here in numerator I am going to divide by 25. So I have to divide denominator also by 25. So what you will get? When you will divide 225 by 25, you will get 9. And when you divide 1250 by 25, you will get 25 5s are 125 and this one 0 is there. So this is 9 upon 50. Now let us take the last question. So here we have to represent 0.239 bar in the form p by q where p and q are integers and q is not equal to 0. That means you have to write down this decimal expansion as a rational number. So let us assume that rational number is x. So we can equate them then. X is equal to 0.239 bar. So there are 3 digits under the bar. So we are going to multiply both the sides by 1000. So here you will have 1000x, and when you multiply this by 1000, you will get 239.239 will be under the bar. So now I am going to subtract first one from the second one. So 1000x minus x will give you 999x. And from this, when you will subtract this, the decimal part will be cancelled out. Only the whole part you will have. So you will have 239. So x is equal to 239 upon 999. So the rational number is 239 upon 999. So now let us take the 7th question. If a is equal to 3 and b is equal to 2, then find the value of a raised power b plus b raised power a. So here in this question, the values for a and b is given to you. You need to calculate the value of this expression. So for that, we will substitute the values of a and b here and find it out. Let us do it. So we have a raised power b plus b raised power a. So the value of a is 3 and b is 2. So we have 3 square here, plus b is 2 and a is 3. So we have 2 cube. So 3 square is 9 and 2 cube is 8. 9 plus 8 is 17. So the value of this expression is 17. Let us now take the 8th question. So is square root of 12 divided by square root of 3 a rational number or not? So you need to find out whether this is a rational number or not. You can see here in numerator you have square root of 12 and in the denominator you have square root of 3. So you are dividing an irrational number by an irrational number. So the answer can be a rational number or an irrational number. So let us solve it and find it out. So square root of 12 upon square root of 3. We can rewrite this as 12 raised to power 1 by 2. And similarly, we can write 3 square root of 3 as 3 raised to power 1 by 2. So using this law, we can solve it. A raised to power p upon b raised to power p is equal to, we can rewrite it like this, a by b whole raised to the power p. So here p, instead of p we have 1 by 2, and instead of a we have 12, and instead of b we have 3. So using this law, let us solve it. So what will you get? You will have it like this, 12 upon 3 whole raised to the power 1 by 2. And you can divide 12 by 3. So what you will get? 4. So inside the brackets you have 4. And this is raised to power 1 by 2. So you know that we can rewrite this as square root of 4, and that is 2. Now let us take the 9th question. Find 32 raised to power 1 by 5. So you need to find out the value of this. So 32 you can rewrite it as 2 raised to power 5. Do the prime factorization and find it out. So 32 raised to the power 1 by 5. So 32 can be expressed as 2 raised to power 5. This is whole raised to the power 1 by 5. So using this law we will solve. A raised to power p whole raised to power q is equal to a raised to power p into q. So you have to just multiply the exponents. So you have 2 raised to power 5 into raised to power 1 by 5. You can cancel it out. So you will have answer as 2. So now let us solve the 10th question. Find the product of 5 root 3. Inside the first bracket you have 3 plus root 3. Inside the second bracket you have 5 plus root 3. So you have to find the product of this. To do that we have to apply distributive law here to solve it. So let us do it. So we have 5 root 3. So now we will apply distributive law here. So 3 into 5 you will get 15. Then you will multiply 3 to root 3. You will get 3 root 3. Then you will multiply root 3 to 5. So you will get 5 root 3. and then you will multiply root 3 into root 3, so you will get 3. So 15 plus 3, you will get 18. So let us write it down. So you have 18. 3 root 3 plus 5 root 3, you will get 8 root 3. Let me explain you how we got this. We can apply distributive law here again to solve it. So you have 3 root 3 plus 5 root 3. So from these two you can take root 3 common. So inside the bracket you have 3 plus 5. So 5 plus 3 is 8. So what will you get? 8 root 3. Again you have to apply distributive law here to solve it. So you have to multiply 5 root 3 to 18. So what will you get? 90 root 3. Then you have to multiply 5 root 3 to 8 root 3. So 8 into 5, you will get 40. And root 3 into root 3, you will get it as 3. So here you have 90 root 3 and 40 into 3 is 120. So now you can leave your answer here. So the product of this is 90 root 3 plus 120. Now let us take question number 11. If 2 raised power 3x into 4 raised power x is equal to 8 raised power 1 by 3 into 64 raised power 1 by 6, then find the value of x. So you need to find out the value of x from here. So let us write it down. So you have 2 raised power 3x into 4 raised power x is equal to 8 raised to the power 1 by 3 into 64 raised to the power 1 by 6. So here 4, 8 and 64. We can express all these numbers with the base 2. Let us rewrite it. So 2 raised power 3x instead of 4, we can rewrite it as 2 square. That is 4 raised power x is equal to, instead of 8, we can rewrite it as 2 cube. This is raised power 1 by 3. 64 is 8 into 8, right? And 8 is 2 cube. So 2 cube into 2 cube. What will you get? 2 raised power 6. So into 2 raised power 6 whole raised power 1 by 6. Now let us simplify it further. So here the bases are same. So we will add the exponents. You can multiply these two numbers. So 2 into x will give you 2x. So you have 2 raised power 3x here and you have 2 raised power 2x. So when you add them, what will you get? 2 raised power 5x. On this side, this 3 and this 3 will be cancelled. When you multiply the powers, similarly when you multiply the powers here, 6 and this 6 will be cancelled. So what will you have here? 2 into 2. So you can add it now, powers. Here the power is 1, here the power is 1 because the base is same. So you have 2 raised power 2 here and here 2 raised power 5x. So 2 raised power 5x is equal to 2 square. So you can see that there is an equal to sign here. So here the base is same. Here the base is 2 and here also the base is 2. So this number is equal to this number and that will only happen when the exponents are also same. So we can write it as 5x is equal to 2. So x is equal to 2 by 5. Now let us solve the 12th question. If x plus root y is equal to 2 minus root 3 whole square, then find the values of x and y. So here in this question, this is given to you and you need to find out the values of x and y. So let us solve. So we have this. So let us use it. X plus root y is equal to 2 minus root 3 whole square. So we can solve this using this formula a minus b whole square. So this is equal to a square minus 2ab plus b square. So in place of a you have 2 and in place of b we have root 3. So using this formula, let us simplify this. So we have x plus root y is equal to 2 square is 4 minus 2. A is 2 and B is root 3 plus B square. That means root 3 whole square. So you will get 3. So 4 plus 3 gives you 7 and here you have minus 4 root 3 and this side you have x plus root y. So here x is a rational number and 7 is a rational number. Here root y is an irrational number and minus 4 root 3 is an irrational number. So let us equate them. So you have x is equal to 7. So you got the value of x and root y is equal to minus 4 root 3. So you have to calculate the value of y. So if we take squares on both the sides, we can get y. So let us square on both the sides. When you square it, what will you get? Y is equal to, if you take the square of this number, so then 4 square is 16 and minus into minus will become plus and root 3 whole square will give you 3. So 16 into 3, you will get 48. So you got the value of x and y. Now let us take the 13th question. What would be the denominator after rationalizing 7 upon 5 root 3 minus 5 root 2? So in this question, it is asked, what would be the denominator after you rationalize it? As of now, you can see the denominator is an irrational number. So you have to convert this irrational number into a rational number. So let us do that. So in the denominator we have 5 root 3 minus 5 root 2. So to rationalize this, I will use this formula square root of a minus square root of b. I am going to multiply this with square root of a plus square root of b. This square root of a plus square root of b, this is conjugate of this number. Here this remains the same. Here it is root a, here also it is root a. Here it is root b, here it is root b. Minus changes to plus. So this is conjugate of this number. So when you multiply this, so what will you get? A minus b. You take the square of root a. So you get a and we write down minus sign and then we take the square root of b and we get b. Same thing we will do for this one and we will rationalize it. So let us solve. So you have 5 root 3 minus 5 root 2. So we will multiply this with its conjugate. So we will write it 5 root 3 plus 5 root 2. So you will get a rational number. So we have to take the square of this number 5 root 3. So let us see. 5 root 3 you need to take the square. So 5 square is what? 25 and root 3 square is 3. So 25 into 3 you will get 75. Similarly, you have to take the square of this number as well. 5 root 2. When you take the square here, 5 square is 25 and root 2 whole square is 2. So 25 into 2 is 50. So when you square them, you get 75 and 50. Let us write it down. So you will get here 75 minus 50. So that is equal to 25. So the denominator is a rational number here and that is 25. So now let us take the 14th question. If 9 is power n into 3 square into 3 is power minus n by 2 whole is power minus 2 minus 27 raised power n divided by 3 raised power 3m into 2 cube is equal to 1 upon 27, prove that m minus n is equal to 1. So here this is given to you and you need to prove this. So we are going to use it to prove this one. So let us write it down. So we have 9 raised power n into 3 square into 3 raised power minus n by 2 whole raised power minus 2 minus 27 raised power n divided by 3 raised power 3m into 2 cube is equal to 1 upon 27. So here you can see that for all these numbers, they are written in exponential form. And for these numbers, the base is 3, and for this number, the base is 2. So let us write down 9 and 27 also in exponential form. So the exponential form for 9 is 3 square, and for 27 it is 3 cube. So this will solve our purpose. So let us write it down. So instead of 9, you can write it as 3 square. This is whole raised power n. So using this law, a raised power p whole raised power q, you can rewrite it as a raised power p into q. So you are multiplying the exponent. So what will you get here? 3 raised to the power 2n. So let us write it down. So here you will have 3 raised power 2n into 3 square. Similarly, for this one also we are going to use the same law. So we will multiply the exponent. So minus n by 2 into minus 2. So minus and minus will be cancelled, and you can cancel this 2 as well. So what will you get? N. So here you have into 3 raised to power n minus 27, you can write it as 3 cube. So this is whole raised to the power n. So using the same law, we will multiply the exponent. So what will you get? 3 raised to power 3n. So let us write it down. So here you have 3 raised to power 3n divided by 3 raised to power 3m into 2 cube is equal to 1 upon 3 cube. So here you can see that the bases are same. So we can add the powers. So 2n plus n will give you 3n. So here you have 3 raised to power 3n plus 2 minus 3 raised to power 3n divided by 3 raised to power 3m into 2 cube. This is equal to 1 upon 3 cube. So from these two numbers you can take 3 raised to power 3n common. So let us take it common. So here you have 3 raised to power 3n. So when you take 3 raised to power 3n common from here, what will be left out? 3 square. You can see that. When you take these two common, what is left out? 3 square. So here you have 3 square and here you have 1. So we have applied distributive property here to rewrite it like this. In the denominator you have 3 raised to power 3m into 2 cube. This is equal to 1 upon 3 cube. So 3 square is 9 minus 1. So what will you get? 8. And 8 you can rewrite it as 2 cube. So you can cancel this. So what you have now? 3 raised to power 3n in the numerator, and in the denominator you have 3 raised to power 3m. Here this side you have 1 in the numerator and in the denominator you have 3 cube. So let us bring this one down. So we will use this law to solve. So a raised to power n is equal to 1 upon a raised to power minus n. So the exponent will become negative. So let us rewrite it. So on this side you have 1 in the numerator now because you are bringing this one down. So in the denominator you already have 3 raised to power 3m and into 3 raised to power minus 3n. This is equal to 1 upon 3 raised to power 3. So here the bases are same. So you can add the powers. So when you add the powers, what will you have? 3 raised to power 3m minus 3n is equal to 1 upon 3 cube. So here you can see that there is an equality sign, and here on both the sides the numerator is 1. So here also the denominator should be equal, then only this side will be equal to this side. And in the denominator you can see the base is same, that is 3. So for the denominator numbers to be same, exponent also should be same. So we can write it like this. 3m minus 3n is equal to 3. So you can take 3 common from here. So what will you get? M minus n is equal to 3. So you can cancel this 3 and this 3. So what will you have here? 1. So what will you get? M minus N is equal to 1. So that is what it is required. So hence proved. Let us now do question number 15. Assertion and reason based MCQs. Directions. In the following questions, a statement of assertion A is followed by a statement of reason R. Mark the correct choice as. So this is an assertion and reason based MCQ. There are two questions over here. This is the first one and this is the second one. The first statement is of assertion, which is followed by the statement of reason. There also the first statement is of assertion and the second one is reason R. After that, you have to choose the correct option from here. So let us start. The first question, assertion A, root 2 is an irrational number. Reason R, the sum of a rational number and an irrational number is an irrational number. So first step is to check whether this is true or false. Even for this, you have to check whether this is true or false. So let us check. Is root 2 an irrational number? Yes, this is correct. Second one, the sum of a rational number and an irrational number is an irrational number. This is also correct. Now the second step is you have to check whether this reason is the correct explanation for this statement or not. So here the reason given is the sum of a rational number and an irrational number is an irrational number. For what? Root 2 is an irrational number. So of course this is not the correct reason. The correct reason is root 2 is an irrational number because it is non-terminating, non-recurring. So this is true, but this is not the correct explanation of this statement. Now let us choose the correct option. So option A is both A and R are true, that is fine, and R is the correct explanation of A, that is not correct. So let us move on to the next option. B option is both A and R are true, but R is not the correct explanation of A. So the correct option is B because both are true and R is not the correct explanation of A. Let us now take the second question. Assertion A number 0.57 bar in the form of rational number P by Q is 29 upon 99. Reason R, decimal expansion of 29 upon 99 is non-terminating and recurring. So the first step is to check whether this is true or false. Similarly, you have to check for this one, whether this is true or false. So let us do that. So here the first statement is a number 0.57 bar in the form of rational number P by Q is 29 upon 99. So let us find out the rational number which represents 0.57 bar. So let us assume it to be x. So x is equal to 0.57 bar. Since there are two digits under the bar, we will multiply both the sides by 100. So here you have 100x and here you will get 57.57 bar. Now we will subtract the first one from the second one. So here 100x minus x, you will get 99x. And here the decimal part will be cancelled. So only 57 will be left. So x is equal to 57 upon 99. So the rational number for this decimal expansion 0.57 bar is 57 upon 99. And what is given over here? 29 upon 99. So this statement is false. Now let us check for the reason whether it is true or false. So the reason is decimal expansion of 29 upon 99 is non-terminating and recurring. So we have to see whether the decimal expansion of 29 upon 99 is non-terminating and recurring or not. So what you have to do? You have to divide 29 upon 99, and when you will divide it, you will get 0.29 bar. So you can clearly see that the decimal expansion of 29 upon 99 is non-terminating recurring. So this reason is true. This is one way to find out whether the decimal expansion of a rational number is non-terminating and recurring or not. There is one more method where you have to just see the denominator of the rational number. If the denominator of the rational number is 2, or you can express it as 2 raised power n, or if the denominator is 5, or it is any power of 5, like 5 square, 5 cube, and so on, or it is a combination of both, then the decimal expansion of that rational number will be terminating. Otherwise, it is non-terminating recurring. So let us see. For 99, you can express 99 as 3 into 3 into 11. When you multiply these numbers, you will get 99. All these are factors of 99. So you can clearly see that you cannot express it like this. So for this rational number, the decimal expansion will be non-terminating recurring. Now let us choose the correct option for the second question. So here A is false and R is true. So you can see here D option. A is false and R is true. So you have to put a tick mark for D option. Let us now discuss question number 16. Case-based questions. Attempt any 4 subparts from the given questions. Read the following text and answer the following questions on the basis of the same. To judge the preparation of class 9 students on the topic real numbers, a math teacher asked the following question. So here case-based questions are asked. A math teacher wants to check the preparation of class 9 students on the topic real number. So he wants to ask these following questions from them. But before that, they need to see the text given over here. So let us start and take the first question. Which of the following is an irrational number? So you need to check which number out of these is an irrational number. So you know the decimal form of an irrational number is non-terminating, non-recurring. And here in the options they have given you only the decimal forms. So let us check one by one. So here you can see the decimal form is terminating. So of course this is not the correct option. Here the decimal form is non-terminating, recurring. So this is also not the correct option. Here it is 3.245, 245 and so on. So you can see that 245, 245 is repeating and it is not terminating as well. So which form is this? Non-terminating, repeating. So this is also not there. Only D option is left out, but let us check. 3.245, 2245, 222 and so on. So you can clearly see that this is non-terminating, non-recurring. So this is an irrational number. You can put a tick mark for this D option. Let us now move on to the second question. What is the decimal form of 2 by 11? You need to find out the decimal form of 2 by 11. So for that you need to divide 2 by 11. So it will go by 1. So you can see again the remainder is repeating. So the question will also repeat. So you will get 0.18 bar. So here B option is having 0.18 bar. So you can put for tick mark for B option. Now let us discuss the third question. Decimal form of 2 by 11 is, you can clearly see that this is non-terminating, repeating. So that option you will find it here in D. So non-terminating and recurring. So you can put a tick mark for D option. Let us now discuss question number 4. Write the P by Q form of 0.38 bar. So you need to write down the P by Q form of 0.38 bar. So let us assume that P by Q form of 0.38 bar is X. So we can equate them. So X is equal to 0.38 bar. Since there are 2 digits under the bar, we will multiply both the sides by 100. So this side you will get 38.38 bar. Now we will subtract the first one from the second one. So what we will get? Here you will get 99x and here you will get 38. So what is the value you got for x? 38 upon 99. So the P by Q form of 0.38 bar is 38 upon 99. And which is that option here? A option. So you can put a tick mark for A option. Now let us take the fifth question. In the fifth question, if P by Q form of 0.38 bar is m by n, then find the value of m plus n. So here P by Q form of 0.38 bar is m by n, and just now we have calculated the value of m by n. What is that? 38 upon 99. So here the value of m is 38 and the value of n is 99. So you can easily calculate the value of m plus n now. Just substitute the corresponding values. So in place of m, write down 38 and in place of n, write down 99. So when you will add them, what will you get? 137. So you will find that A option has got 137. So you can put a tick mark for A option. So you must have noticed that the questions are really good and would definitely help you to score good marks in your exams. So if you want to solve such challenging questions, click on the link given in the description box below and purchase it right away.